Okay, so this video tutorial looks at the mathematical strand of geometry, and more specifically, we're going to focus on some further circle geometry theorems. Now, the first theorem that we're going to look at is called the angle at the center of a circle. So the angle at the center of a circle is twice the size of the angle at the circumference. Now, this is only when it is subtended or joined or formed from the same arc. So remember that the arc of a circle is a section of the circumference. I'm drawing it in blue on my first diagram here. That's my arc. It's from A to B. And we have our first angle created to the center of the circle from A and B. So this is the angle AOB. Okay. We have a second angle that's created at C using the same arc. All right. I got a bit excited there. So this is the angle of ACB, and we can tell that the red angle, okay, is actually 2 times as big as our green angle. All right. So therefore, the angle AOB must be 2 times the angle of ACB. Now, it's important to realize as well that here, the angle of AOB is actually less than 180 degrees. All right. If it was more than 180 degrees, so look at our second diagram here. We've got an angle here because we've got an arc that runs around this way. Okay, an arc that runs around this way. So we've got point A and B. Okay, there's our arc. And then we have an angle here, which is in red, around here. And let's say we wanted to do another angle in green to C. Okay, to point C, we've got an angle there. Then this angle, if we call that, hang on. Okay, the second angle theorem that we're looking at, or circle theorem we're looking at, involves the angle subtended by the same arc. So angles drawn from the same arc. Now remember that an arc is a section of our circumference. I'm drawing it at the moment in blue between the points B and C. All right, and you can see that what that has done is it has allowed me to create an angle at D, from those 2 points. It's also allowed an angle created at E from those 2 points. And we know that this theorem suggests that those 2 angles are the same. Now this theorem is actually supported by our previous theorem we've just looked at, because C and B can also form an angle with the center of our circle here at A, and that angle is actually twice as big as the other angles that are on our circumference, which agrees with our first theorem. So we can state from this theorem that if 2 angles are on the circumference and they are drawn from the ends of the same arc, then they are equal. So in this particular case, the angle of BDC must be equal to the angle of BEC. Okay, so the third theorem that we're going to look at in this video tutorial is the angle created between a tangent and a chord. Now, remember that a chord is a line, I'm drawing in blue, that passes through a circle, right? Not through the center, that's the diameter. The chord passes through part of a circle, and the tangent is a line that touches the circumference but doesn't pass through the circle. All right, when these 2 lines meet, they create an angle. In this particular case, the angle is theta. Now, it's important to understand that this angle is equal, okay, to the opposite internal angle, all right, or also known as the alternate segment, okay. So this part up here is the opposite internal angle, or also known as the alternate segment. Okay, this is really well demonstrated on our second diagram where we can see colored in green, we have an angle here created between our chord and our tangent. I'll use the same colors so we don't get confused. So we've got an angle created here, and that is also the same as the angle here, this alternate segment, and the angle here created between our chord and our tangent. Okay, the last theorem we're going to look at in this video tutorial talks about cyclic quadrilaterals. Now, a cyclic quadrilateral is essentially a four-sided shape that's inside a circle where all of the points on the four-sided shape touch the circumference. Okay, and if that happens, the opposite angles are supplementary, meaning they add up to 180. So if we add some variables in here to give measurements to our angles, then we can say that A plus C must equal 180 and B plus D must also equal 180. They are supplementary. Now, it's important to know too that the external angle of a cyclic quadrilateral is actually equal to the opposite internal angle here. So we can see here that the external angle at A is equal to the internal angle at A over here. Okay, so here are some practice questions I'd like you to have a go at. Please feel free to pause the video. When you think you've got them all correct, continue the video and we'll see how you went. Okay, so let's see how you went. Now, each one of these four circles relates to the four theorems we've looked at. Obviously, in our first question, these two angles are formed from the same arc, okay, the arc of A and B. We know that when that happens, both angles must be the same. So therefore, x must equal 30 degrees. In B, we've got a cyclic quadrilateral, and the opposite angles of a cyclic quadrilateral are supplementary, meaning that M must equal 180, take 95, and therefore M is going to equal 85 degrees. In our third question, we know that the center angle is twice the size of the circumference angle. So therefore, x must be 110 divided by 2. And therefore x is equal to 55 degrees. And in our last question, we know that the angle made between a chord, which is here, and the tangent, which is there, is the same as the opposite internal angle here. So therefore x must equal 70 degrees.